Hello students, today I am going to discuss another very important topics, that is electrophilic substitution reaction. You will get at least 2 questions in NEET or JEEMAINS. So understand what are electrophiles. So the first question is, what are electrophiles? I have seen questions in entrance on these topics. Number 1, any positively charged ions act as electrophiles. In chemistry, any positive charge ion act as electrophile. Any positive charge ion acts as electrophile. There are another electrophiles which are called Lewis acids, also act as electrophiles, such as aluminium trichloride, ferric chloride, etc. What are Lewis acids? Listen, if you consider the structure of aluminium trichloride, it has 6 bonding electrons, 1, 2, 3, 4, 5, 6. So the central aluminium has a shortage of 2 electrons from octet. That's why this type of compounds act as Lewis acids and they are used as electrophile in organic chemistry. Number C, there are another compounds which act as electrophile if 2 nonmetals having different electronegativity, are attached to multiple bonds, then the more electronegative element drags electron towards it, and so the central metal has a shortage of electrons, act as electrophile. For example, if you consider carbon dioxide, carbon and oxygen are both nonmetals. Oxygen is more electronegative. Hence, oxygen has a tendency in both sides to attract the pi bonding cloud towards it. So there is a shortage of electron on the central carbon atom, and thus the carbon, actually the compound, but the carbon acts as electrophile center. So remember, this is very important topic. When 2 nonmetals are attached to multiple bonds, okay, when 2 nonmetals are attached to multiple bonds, then the nonmetal having more electronegative attracts the pi bonding cloud towards it. So there is a shortage of electron on the central carbon atom. Thus, this type of compounds act as electrophile. Another type of compound which also act as electrophile, they are the compounds which have vacant d orbital at the central atom. They are the compounds which have vacant d orbital at the central atom, also act as electrophile. Due to the presence of vacant d orbital in them, they can donate electrons, so can act as electrophile. So this type of compounds are electrophiles. Any positively charged ions, Lewis acids which have a deficiency of 2 electrons from octet. This type of compounds where 2 nonmetals are attached by multiple bonds and the most electronegative element attract the electron towards it. So the central metal acts as electrophilic center. There are some compounds due to the presence of vacant d orbital, they also can act as electrophile. So these are the electrophiles, okay. Now any substitution reaction where one electrophile is substituted by another electrophile is called electrophilic substitution reaction. Actually remember it, introduction of any atom or group on benzene ring is an example of electrophilic substitution reaction. So remember it, introduction of any atom or group on the ring, on the benzene ring, is an example of electrophilic substitution reaction. So see the most important electrophilic substitution reaction in organic chemistry, okay. Remember it, you will get 2 to 3 questions in any entrance, whether medical or engineering in all India level, from electrophilic substitution reaction. So the best example of electrophilic substitution reaction is, notes, okay, Friedel-Crafts reaction. This is the best known example of electrophilic substitution reaction, okay. That's the Friedel-Crafts reaction. Clear? So do you know what are Friedel-Crafts reaction? During Friedel-Crafts reaction, alkyl group or aryl group are introduced on benzene, okay. During Friedel-Crafts reaction, alkyl or aryl group introduced on benzene ring. So introduction of alkyl or acyl group on the benzene ring are example of Friedel-Crafts reaction, okay. Are example of Friedel-Crafts reaction. So now listen. Number 1, alkylation. So introduction of alkyl group on benzene is called alkylation, okay. Introduction of alkyl group on benzene called alkylation. How to introduce? Say, listen, you have benzene with you. This is benzene. When you want to introduce an alkyl group on benzene, say methyl is introduced, you get toluene. What is the technique behind it? Just use its halide, chloride, bromide. Say chloride is used. In this reaction, one catalyst is used, that is anhydrous aluminium trichloride. So listen, this reaction occurs via carbocation as intermediate. Okay, you can write FRIE, that's the correct. Okay, Friedel-Crafts. So mechanism is necessary to understand a reaction. Okay, step 1, formation of carbocation of intermediate, that is carbocation. Methyl chloride, aluminium trichloride, as you know, it is a Lewis acid. So as it has a deficiency of a pair of electron, so it attracts the electron pair from this bond. So you see the carbon loses its own electron. By losing electron, this methyl group becomes positively charged, plus AlCl4. So it's an electrophile. You know that any positively charged ion called electrophile. Nowadays it is called attacking reagent. Okay, nowadays it is called attacking reagent. And in step 2, this electrophile is attached on benzene. This electrophile is attached on benzene, and thus you get CH3 plus from benzene hydrogen positive ion, that is another electrophile is replaced. So you know, during electrophilic substitution reaction, one electrophile acts as incoming electrophile, enters into the ring, and from the benzene ring another electrophile, that is H positive ion, that's a proton, is replaced. That's why this type of reactions are called electrophilic substitution reaction. Remember it, introduction of any atom or group on benzene is the best example of electrophilic substitution reaction. So I think you understand it. So whenever you want to replace the hydrogen atom of benzene by any alkyl group, remember it, that's the example of Friedel-Crafts reaction, FRIE actually, okay, Friedel-Crafts reaction. So do it now. This is the very important questions for your time, okay? See the question. Remember it, Friedel-Crafts reaction is going on, okay? Inside it, one very important question, write it. This is benzene. Reacts with CH3, CH2, CH2Cl. Methyl ethyl propyl chloride. In presence of anhydrous aluminium trichloride. What will happen? Remember it, during any reaction in organic chemistry, if carbocation is formed as intermediate, there is a chance of rearrangement of carbocation to maintain the stability order. You know that the decreasing order of stability of carbocation is tertiary greater than secondary greater than primary. Okay, so the main thing is mechanism. During this reaction, as you know, As aluminium trichloride acts as Lewis acid, so it attracts the bonding electron cloud from chlorine atom. Okay, so you get CH3, CH2, CH2 positive plus AlCl4 negative. This is primary carbocation. You know that if the positively charged carbon contains two hydrogen atom primary, one hydrogen atom secondary, no hydrogen atom tertiary. Now this carbocation undergoes rearrangement. This carbocation undergoes rearrangement, okay, and thus one hydrogen atom you can draw this way also, okay, it will be easier. This hydrogen shifts here, 1, 2, hydride shift. Hydride shift means H negative ion called hydride. So this carbon actually loses the electron. So you get CH plus and then CH2 and H CH3. This is isopropyl carbocation, okay? Isopropyl carbocation. It's a 2-degree carbocation, secondary carbocation, okay? It's a 2-degree carbocation, secondary carbocation. So this is the electrophilic center. So this carbon gets attached with the benzene ring. This carbon now attached with the benzene ring. This carbon now attached with the benzene ring, and you get CH, CH3, CH3 as the main product, okay, and it's called cumene. This is the electrophilic center. So I think you understand it. During any reaction, if carbocation is formed as intermediate, remember it, there is a chance of rearranged to maintain the stability order. Okay. Now do one very important questions. Say options are there, okay? Options are there. Benzene reacts with methyl chloride in presence of aluminium trichloride. Product A we get. When A reacts with alkaline solution of potassium permanganate, you get B. Another thing, A also reacts 2 steps. One with Cr, O2, Cl2 and CS2, then hydrolysis, you get C. What are B and C in these reactions? Listen here, B is benzoic acid and C is benzaldehyde. this reaction is called, you know that, Ettard reaction. This reaction is called very important reaction, okay, in organic chemistry. So you get two products. B is benzoic acid and C is benzaldehyde. So remember the reaction. This is very important reaction for your time, okay. Now another question. You know that there are two types of Fidelka reaction. Introduction of alkyl group called alkylation, which already I have covered. Now introduction of acyl group on benzene ring. This is acyl group RCO. And if you introduce acyl group on benzene, then the reaction is called Friedel-Crafts acylation reaction. Okay, then the reaction is called Friedel-Crafts acylation reaction. So listen the acylation reaction. Acylation reaction, okay. Introduction of acyl group on benzene. RCO. Acyl group. Introduction on benzene is called acylation, okay. Now same technique when benzene, if you want to introduce COCH3, it is called acetophenone. Now how to write the product? I have already told you that the group which you introduced on benzene, use it. This is a benzene, okay. Chloride compound. So it is acetyl chloride. In Fidelka reaction, anhydrous aluminium trichloride always acts as. So from benzene, hydrogen is removed. This hydrogen combines with chlorine to form HCl. This is the electrophilic center, okay. Whenever you introduced any group on benzene, remember it, the electrophilic center gets attached to benzene. This is the electrophilic center here. Can you prepare it, this product? How do you prepare this product? First tell me what is your name. What is its name? It's called benzophenone. This is benzene. When reacts with this part, benzene having COCl in presence of aluminium trichloride, so it's called benzoyl chloride. ZOYL, benzoyl chloride. If benzene contains COCl, benzene, this group is called benzoyl. Benzene having CO on the head, and this is called benzoyl chloride, okay. Now I think you understand the Fidelka reaction. Do the two another important questions regarding Fidelka reaction, okay. So remember it, Fidelka reaction is the best known example of electrophilic substitution reaction. So this is the question I have seen in entrance. reaction is not given here, okay? So what is the answer here? Benzene reacts with CH3COCl in presence of AlCl3, you get A. A when reacts with zinc, mercury, amalgam and then hydrolysis, you get B. B when treated with alkaline, potassium permanganate, you get C. What is C? What is the product of C here? Listen. Answer. Benzene when reacts with, this is acetyl chloride. In presence of anhydrous aluminium trichloride, you know that this is a part of Friedel-Crafts reaction. This is a part of Friedel-Crafts reaction, okay? Friedel-Crafts reaction. This is the electrophilic center. This carbon is attached to benzene. COCH3. You get acetophenone. And this is A. According to the question, this is A. Now, when A reacts with zinc, mercury, amalgam, and then hydrolysis, you know that this reaction is called Clemmensen reduction. The reaction is called Clemmensen reduction, and during Clemmensen reduction, the carbonyl group will change into methylene group. During Clemmensen reaction, the carbonyl CO group of aldehyde and ketone will change into methylene group CH3. So you get ethyl benzene. This is B according to the question. B on oxidation with alkaline potassium permanganate. B on oxidation with alkaline KMnO for potassium permanganate. You know that any alkyl group when attached to benzene, irrespective of the number of carbon atom, undergoes oxidation in presence of alkaline potassium permanganate. Whole of the alkyl group will change into single unit of carboxylic acid group. So you get benzoic acid. So there are lots of electrophilic substitution reactions. See the another electrophilic substitution reaction, okay? And in most of the electrophilic substitution reaction, one electrophile is attached to benzene, and from benzene, one hydrogen positive ion is removed. So see the another electrophilic substitution reaction, that is Gattermann Koch reaction. Gattermann Koch reaction, okay? You know that when benzene reacts with a mixture of carbon monoxide and hydrogen chloride in presence of aluminium trichloride and copper chloride, so the reaction is benzene when heated with a mixture of carbon monoxide and hydrogen chloride. When benzene is heated with a mixture of carbon monoxide and hydrogen chloride at around 300 Kelvin temperature under some pressure, no need to remember in entrance, in presence of AlCl3 and copper chloride, aldehyde group is introduced on benzene, okay? Aldehyde group is introduced on benzene. So you get benzaldehyde. The reaction is known as Gattermann-Koch reaction. Now the question is, this is the direct question, or you see the electrophile in this reaction is the electrophile or attacking reagent. Same thing, okay? Is. Can you tell me what is the electrophile here? The electrophile here is HCO. This is the electrophilic center. Okay, this is the electrophilic center, and the electrophile is called formyl electrophile. This is the electrophilic center, and it gets positive charge. Okay, this carbon gets positive charge, and this electrophile is called formyl. There is another reaction. Okay, can you tell me what is the name of the reaction and what is the attacking electrophile here? Can you tell me what is the name of the reaction and what is the attacking? Now tell me the product. What is product is the main in this reaction? What is the name of the reaction? The reaction is called Gattermann aldehyde synthesis. And in this reaction also we get benzaldehyde. See, you have benzene, you get it. So obviously it is an example of electrophilic substitution reaction. Here also you get benzaldehyde. Now the question is that what is the attacking reagent or electrophile here? Okay, the attacking reagent or electrophile is not here formyl electrophile. No, here the attacking reagent or electrophile is this CH positive double bond NH. By the reaction of this it is formed. No need to remember the mechanism. Remember directly, this is the attacking reagent or electrophile in this reaction. Okay, and it is called formaldimine. Formaldimine. This is the imine. Formaldehyde comes from formaldehyde. That's why it is called formaldimine. So next topic regarding Friedel-Crafts reaction. Okay. Listen now. If benzene contains substituent, then if the substituents are meta-directing nature, generally Friedel-Crafts reaction does not take place. Notes, important notes regarding Friedel-Crafts reaction. Presence of meta-directing groups. I have already discussed in earlier videos what are meta-directing groups. Okay, I have already discussed meta-directing groups. So presence of meta-directing groups such as nitro, such as aldehyde, such as ketone, such as carboxylic acid, such as cyano group. If this type of groups are present on benzene, the compounds do not undergo Friedel-Crafts reaction. Remember it. If any meta-directing group is present on benzene, they do not undergo Friedel-Crafts reaction, as the ring is deactivated due to electron attracting nature of them. For example, this is benzoic acid, COOH. When you want to undergo Friedel-Crafts reaction, actually no reaction takes place. Similarly, nitrobenzene, benzaldehyde, acetophenone, cyanobenzene, they do not undergo. So remember it, any meta-directing group which drag electron from benzene decreases the reactivity of benzene. That's why in that case Friedel-Crafts reaction does not occur. But if any orthopara-directing group is there, then benzene attracts electron from them. So electron density on benzene increases, and at that time they undergo easily Friedel-Crafts reaction. But one exceptional case is there, aniline. Aniline or aromatic amine do not undergo Friedel-Crafts reaction. So remember it, aniline, though it has orthopara-directing nature, though benzene attracts from amino group, but aniline is unable to undergo Friedel-Crafts reaction. So remember it, aniline or any aromatic amine do not undergo Friedel-Crafts reaction. Why? Listen now. Because you know that in Friedel-Crafts reaction, aluminium trichloride is used as catalyst. It's a Lewis acid, that also you know. As nitrogen has lone pair of electron, so this gets attached with the lone pair of electron of nitrogen atom, and thus the nitrogen becomes positively charged. So you get aniline ion, and as nitrogen becomes positive charge, as nitrogen is more electronegative than carbon of benzene, so nitrogen attracts electron from benzene. That's why positive charge, partial positive charge is developed on benzene, and hence the reactivity of the ring decreases. You can say the ring is deactivated for further electrophilic substitution reactions. Hence, aniline does not undergo Friedel-Crafts reaction, okay, though it has orthopara directing nature, though benzene attracts electron from it. So see the reactions. This is a compound. Actually this is methyl ethyl propyl chloride, okay. This is propyl chloride benzene. Do you know these are actually Friedel-Crafts reaction? What happens here? Directly, you know that in benzene every carbon contains one hydrogen atom. So just attach it. So you get the product here. This is the product, okay? This product you get. It is called tetraline. Just this hydrogen and the chlorine they remove. Can you tell me what is the name of the reaction? These both two are examples of intramolecular Friedel-Crabbe reaction. And during intramolecular Friedel-Crabbe reaction, whether it is intramolecular alkylation or intramolecular acylation, in both of the cases cyclic ring is formed. Here also you get the product here. Name is not important here. Final product is important here, okay? So it is called 1-hydrinone. 1-hydrinone. Name is not important. The product is important. So both are the examples of intramolecular Friedel-Crabbe reaction. Intramolecular. During intramolecular Friedel-Crabbe reaction, whether it is alkylation, this is alkylation, you know that this is a part of alkylation and this is a part of acylation. In both of the cases you get cyclic ring structure, okay? You get cyclic ring structure. So I think you understand the reactions, okay? Today's topics. So please subscribe my channel and you will get more and more important videos on your forthcoming entrance exam. So thank you.